Hello everyone, welcome to the Sunshine State, where the warmth of the sun greets you the moment you step onto the sand. I'm standing here on one of Florida's breathtaking beaches, and let me tell you, the sun here isn't just bright, it's absolutely radiant, casting a golden glow over everything it touches. The sky is a brilliant blue and the air is filled with the sounds of laughter and waves. The sand beneath my feet is soft and warm, almost like a gentle hug from the earth itself. And just beyond, the ocean stretches out in a dazzling shade of turquoise, sparkling under the sunlight. It's the kind of place that makes you want to kick off your shoes and dive right in. People from all corners of the world travel here, drawn by the promise of gentle waves and the soothing embrace of the sea. Some are swimming, others are simply relaxing, letting the rhythm of the ocean wash their worries away. It's a scene of pure joy and relaxation. But what's truly fascinating is that the warmth and energy found here don't just stay on these shores. Instead, they set off on an extraordinary journey, traveling far beyond Florida, out into the vast expanse of the Atlantic Ocean. This journey is one of nature's most remarkable and awe-inspiring stories, a story that connects continents and shapes climates across the globe. Picture, if you will, a massive, invisible river flowing through the ocean. This isn't a river of fresh water, but a powerful current of warm, tropical seawater, moving with incredible force and purpose. This mighty oceanic river doesn't just move water, it moves heat, influencing weather patterns for millions of people. Its effects can be felt thousands of miles away, shaping the climate of entire continents. In fact, it plays a crucial role in determining whether winters in Europe are mild and rainy, or bitterly cold and snowy. Without this current, the climate in places like London or Paris would be dramatically different, much colder and harsher. And the incredible thing is, this global climate engine begins its journey right here, in the warm, sheltered waters of the Gulf of Mexico, just off the coast of Florida. Every single second, this current moves more water than all the world's rivers combined. A truly staggering amount of energy and motion, all set in motion by the sun's heat. This incredible phenomenon is known as the Gulf Stream, a name that has become legendary among scientists, sailors, and anyone fascinated by the power of nature. So join me as we dive deeper into the story of this mighty ocean river, exploring how the Gulf Stream shapes our world, influences our weather, and connects distant lands in ways you might never have imagined. So what exactly is the Gulf Stream? It's a name you might have heard in weather reports or science documentaries, but what does it really mean? The Gulf Stream is one of the most powerful and influential ocean currents on our planet, and its effects reach far beyond the waters it flows through. Imagine a gigantic invisible river surging through the Atlantic Ocean at speeds that can reach up to 5.5 miles per hour. This isn't just any current, it's a force of nature, moving more water than all the world's rivers combined. The journey of the Gulf Stream begins in the sun-drenched waters of the Gulf of Mexico. Here, the sun's energy heats the ocean's surface, creating a pool of warm water that's lighter and more buoyant than the cooler water around it. This warm water is then funneled out of the Gulf, squeezing through the narrow Florida Straits, the passage between the southern tip of Florida and the island of Cuba. It's like a bottleneck, accelerating the flow as it enters the open Atlantic. Once in the Atlantic, the Gulf Stream hugs the eastern coastline of the United States, stretching from Florida all the way up to North Carolina. From above, it looks like a shimmering blue ribbon, distinct from the darker, cooler waters around it. But the Gulf Stream is more than just a current. It's a massive conveyor belt for heat. As it travels northward, it carries vast amounts of tropical warmth toward the colder regions of the North Atlantic, redistributing energy across the planet. Satellites equipped with thermal imaging can actually see the Gulf Stream's path, tracing a glowing trail of hot water as it snakes through the cooler ocean. This visible difference in temperature is a testament to the current's power. The scale of the Gulf Stream is staggering. In some places it stretches over 60 miles wide and plunges nearly a mile deep, making it one of the largest and most significant currents on Earth. After reaching North Carolina, the Gulf Stream makes a dramatic turn eastward, heading out into the vast Atlantic. As it moves, it gradually releases its stored tropical heat into the atmosphere, influencing weather patterns across the ocean. This process is crucial for the climate of Northern Europe. Thanks to the Gulf Stream, places like the United Kingdom and Norway enjoy much milder winters than other regions at similar latitudes, which would otherwise be much colder and snowier. In essence, the Gulf Stream is a river of life and warmth connecting continents, shaping weather, and supporting countless marine species along its path. Its influence is felt by millions of people, making it one of the most important natural systems on our planet. What gets this colossal river of water moving? The Gulf Stream, one of the most powerful currents on Earth, is like a vast conveyor belt, transporting warm water thousands of miles across the Atlantic. But what exactly sets this mighty flow in motion, and keeps it running day and night, year after year? It's a combination of powerful natural forces, each playing a unique and essential role. These forces work together in a delicate balance, creating a system that is both robust and sensitive to change. The sun is the first ingredient, heating the ocean surface near the equator. Its energy pours down relentlessly, especially in tropical regions, warming the upper layers of the sea and setting the stage for everything that follows. This creates a pool of warm, less dense water in the tropics. The heat causes the water molecules to move faster and spread apart, making the water lighter than the cooler, denser water found farther north. Water naturally moves from areas of high energy, where it's warm and less dense, to areas of lower energy, where it's cooler and denser. This difference in energy sets the water in motion, beginning its long journey northward. The second force is the wind. Trade winds, which blow steadily from east to west near the equator, push the surface water westward, funneling it into the Gulf of Mexico. These winds act like invisible hands, guiding and accelerating the flow of water. This wind action creates a powerful jet-like current. The water is squeezed through the narrow Florida Straits, picking up speed and forming the core of the Gulf Stream as it surges north along the coast. But the journey doesn't just follow a straight line. The Earth's rotation introduces another force, the Coriolis effect. As the planet spins, moving water is deflected to the right in the northern hemisphere, turning the current northward and shaping its path along the eastern coast of North America. Without the Coriolis effect, the Gulf Stream wouldn't exist as we know it. The current would simply flow westward, never making its iconic turn toward Europe. Finally, salt plays a crucial role. As the warm water travels north, it cools and evaporates, leaving behind salt and making the water even denser. This process is called thermohaline circulation, and it helps drive the deep ocean currents that complete the global conveyor belt. This dense, salty water eventually becomes heavy enough to sink deep into the ocean, pulling more surface water up from the south to replace it. This sinking action is like a giant engine, powering the continuous flow of the Gulf Stream. The sun provides the heat, the wind provides the push, Earth's spin provides the turn, and the sinking water provides the pull. Each force is vital, and together they create a dynamic, ever-changing system. It's an incredible system of interconnected forces, a masterpiece of nature that shapes our climate, supports marine life, and connects continents. The Gulf Stream is more than just a current, it's a lifeline for our planet. For those on the U.S. East Coast, the Gulf Stream is a major player in their weather. It dramatically affects hurricane season, fueling storms with warm ocean water. The current provides thermal energy, allowing storms to intensify rapidly. The Gulf Stream also creates unique weather patterns along its edge. The boundary between warm and cold water creates fog, especially in winter and spring. During winter, the Gulf Stream acts like a warm blanket for the East Coast. Coastal areas experience milder temperatures, often avoiding snowstorms. The warm waters allow tropical species to travel farther north. The Gulf Stream is a life-giving artery for the Atlantic Ocean. To appreciate the Gulf Stream's impact on Europe, compare London, England, and Nain, Labrador. Both are at similar latitudes but have vastly different winters. London is cool and damp, with mild winters thanks to the North Atlantic Current. Nain experiences harsh, unforgiving winters with deep snow and ice. The Gulf Stream's warmth makes London's climate milder. Without it, London would have winters like Labrador's. The Gulf Stream shapes the history, culture, and agriculture of Europe. It's a powerful reminder of ocean currents as hidden architects of our world. The Gulf Stream is a climate regulator, pasting tropical warmth onto northern latitudes. It's a testament to the interconnectedness of our planet. The Gulf Stream's impact extends globally, affecting weather patterns far away. It interacts with the atmosphere, influencing the jet stream's position and strength. This interaction can cause unexpected weather events deep within continents. The Gulf Stream is part of the Atlantic Meridional Overturning Circulation, AMOC. This circulation helps distribute heat globally and influences rainfall in Africa. A strong AMOC brings vital monsoon rains to the Sahel region. The Gulf Stream is a critical component of a planetary life support system. The Gulf Stream faces a serious threat: climate change. Melting ice sheets in Greenland add cold, fresh water to the ocean. This fresh water disrupts the Gulf Stream's engine, preventing efficient sinking. A slowdown of the Gulf Stream is a real possibility. The Atlantic circulation is weaker today than in over 1,000 years. A significant slowdown could happen in the coming decades. The Gulf Stream has been a reliable climate regulator for millennia. Our actions threaten to disrupt this ancient ally. A significant slowdown of the Gulf Stream would have global consequences. Northern Europe could experience much harsher winters. A weaker Gulf Stream would lead to warmer ocean temperatures along the U.S. East Coast. This could intensify hurricanes and cause faster sea level rise. A slowdown would shift the tropical rain belt, leading to droughts in Africa. It would also harm fisheries by expanding low-oxygen dead zones. A slowdown represents a tipping point in our climate system. It would trigger a cascade of effects, altering weather patterns and ecosystems. We must stabilize our climate before pushing natural systems past their breaking point. The Gulf Stream is a testament to the connections that govern our world. It's a lifeline, climate regulator, and global engine supporting life for millennia. Understanding this ocean river is key to appreciating our planet's climate balance. The threat of a slowing Gulf Stream is a serious warning. Our actions have consequences that reach the deepest corners of our world. Protecting these currents is essential for maintaining a stable climate. We have the knowledge and technology to make a change. By transitioning to clean energy and protecting our environment, we can stabilize our climate. Every action matters, from individual choices to government policies. Let's work together to protect our oceans and ensure the Gulf Stream's journey continues.